Okay, so let's have a look at the Leaving Cert Higher Level Maths Paper 2 for 2022, and this is question 6. Now, this is a geometry type question, and first thing we have to do is construct a circumcenter of the triangle XYZ shown below using a compass and a straight edge. Label the circumcenter C and show your construction lines clearly. Okay, so I'm not going to be able to do this on the computer, but I'll just generally do it freehand, and I'll put a link in the description. I have a separate video on how to do circumcenters and circumcircles. So basically what you do is you need to start here. Just put your compass here, bring your pencil out as far as, let's say, here, and draw an arc up here somewhere. What you do then is draw another arc down here somewhere. And then without moving the compass, bring your compass over here and draw two more arcs, one here and one here. And then what you're going to do is you're going to join up those two lines there. Now this will be perpendicular bisector of the line segment XZ. You do the same with either one of the other two sides. So let's say if we take this one here, you would start at Z here, do an arc, start at Y here then, arc, and you would connect these up here. Now that's not very good at all, but you get the idea. You get another perpendicular bisector here. So this would be equal to this would be equal to this, and your circumcenter will be down here somewhere. So you guys will need to use a compass and a ruler or a straight edge to do this. Okay, so that's part one. It says label the circumcenter as well, by the way, so make sure you do that. So label it C, show your construction lines clearly. So that would mean you would need to show these arcs and these perpendicular bisectors as well. Okay, so look, part B then. We have the points A, B, and C, and D. So A, B, C, and D here, they lie on a circle as shown in the diagram on the right. It's not to scale. AB is the diameter of the circle, so this is the diameter here. So that would mean this angle up here, which is an angle in a semicircle, would be 90 degrees. What else we have here? AB is the diameter. The angle DAC is 40, so we're given that. And the triangle ABD is isosceles. ABD, so ABD is isosceles, which means that side there would be equal to that side there, and this angle here would be equal to this angle here. Find the angle ADC. So find the angle ADC. So we got to find this angle here. So usually what I would do when I'm doing these is just write in all the bits and pieces, the angles and the sides and so on that I know at this stage. So let's see. This angle here is 90 degrees. So that's going to be 90 degrees up there. It's because it's an angle in a semicircle. So you can write that down. The angle ADB is equal to 90 degrees. The reason, angle in a semicircle. Now, if that's 90 degrees and this here is an isosceles triangle, that means all we've got to do is take 180, subtract 90 and divide by 2. That'll give us this angle here and this angle here. So let's do that. So I'm going to say 180 degrees minus 90 degrees divided by 2. That's going to be equal to angle DAB and it's also going to be equal to angle DBA. And when you work that out, you get 45 degrees. So both those angles are 45 degrees. This angle here is 45 degrees. This angle here is 45 degrees, which means this angle here must be 5 degrees here. The entire angle is 45 degrees. So that means CAB, the angle CAB, is equal to 5 degrees. Okay, so let's see what we can do with that. Okay, so also if we look here, we can see that angle ACD and angle ABD, they both stand on this arc here. So they both stand on this arc here, so that means that this angle is 45 degrees and this angle here must be equal to 45 degrees as well. So that means angle ACD is equal to 45 degrees. So angles standing on same arc. So I can say, you know, that that's equal to angle ABD. This angle here then is also 45 degrees. And remember, we've got to find the angle ADC. So that's ADC. Okay, so if this is 45 degrees here, and this is 40 degrees here, all we've got to do is add these two here, subtract from 180, that'll give us this angle here, ADC. So let's do that. So it's 180 degrees minus 40 minus 45. So it's 180 degrees minus 40 degrees minus 45 degrees. That's going to be equal to the size of the angle ADC. And what you get when you do that is 95 degrees. And that's it there then. Okay, and we didn't actually need the 5 degrees here, but we got there anyway eventually. Okay, so let's look at the next part, the last part of this question. Now this one here I thought was a little bit tricky, took me a little bit of thinking about. It's probably, this particular question is probably one I would have avoided in the exam, but some of you may have found it easy enough. Let's have a look at it anyway. We have the diagram on the right. It shows a triangle PQR. So this is our triangle here, PQR. It's not the scale. The angle OR is greater than 90 degrees. This angle here is greater than 90 degrees. K is the circumcircle and of PQR is shown, and O is the circumcenter. O is not there. So prove that O cannot be inside the triangle PQR. If you're proving this by contradiction, your first line should be this thing here. Okay, assume that O is inside, and then prove that there's going to be some kind of contradiction. Show that there's going to be some kind of contradiction later on in the proof. Okay, so you can probably see intuitively, you know, that if PQ was a diameter, then, you know, this is going to be 90 degrees here. And if PQ moves down this way, so in other words, if PQ is down here, this angle here is going to get smaller. And if PQ moves up along this way, P or Q is going to become greater than 90 degrees. So intuitively you can probably see that this is going to work. But let's just work through this proof anyway. We're going to start by assuming that O is inside the triangle PQR. So we're going to start by assuming that O is, let's say, here. If that is a circumcenter, it means that how we found that circumcenter was we drew a perpendicular line from here, we drew a perpendicular line from here, and usually we stop there, but let's say we did the third one as well. We dropped a perpendicular down here, perpendicular bisector here as well. So that's a right angle, that's a right angle. These are all right angles here. And also that side is equal to that side, that's equal to that, that's equal to that there. Okay, so the other thing about a circumcenter is we could have drawn this circle by using a compass and putting the pin of the compass here, pencil out here, and drawing this circle. In other words, the distance from here to OR, from here to P, and the distance from O to Q, from here to Q, are all going to be the same. They're all going to be radii of the circle. So let's just draw that in. So let's say we have a line from P out here, so that's one radius. We have a line up here to OR, that's another radius, and we have a line down here to Q, that's our third radius here. They're all equal. Now remember again, this here is going to be equal to this one here, is going to be equal to this one here, because they're all radii. Now let's just identify all of these angles at this stage. So let's use a different color here. Let's use green. So let's say this is angle alpha. So this has to be alpha here because we're dealing with an isosceles triangle. This is going to be beta here. This is beta here. And let's say this is gamma and gamma here. So we've identified all our angles. Now, well, actually what I'll do is I'll identify some angles in the middle as well. So I'm going to identify all of these angles in the middle. So this is angle number 1. This must also be angle number 1 here, because this is an isosceles triangle and we've dropped the perpendicular down along here. That means these two angles must be the same. Similarly, this angle must be equal to this angle, and this angle here must be equal to this angle here. So let's just identify all of these. This must be 2, this must be 2, and we'll call this one 3 and 3. So we've identified all our angles. So we're going to start here by assume that O is inside triangle PQR. The way we normally start these things is we would say what we're given. So we're given a circle K and triangle PQR as shown. To prove, we want to prove that O, the center, circumcenter, the circumcenter cannot be inside the triangle PQR. Construction. So draw the perpendicular bisectors. As shown. Draw and segments from O to P, Q, and R as shown, and then finally just label the angles as shown. Okay, so that's given to prove construction. So the actual proof then, okay. So we're going to start with this here. We're going to use this here. Assume that O is inside the triangle PQR. So we're going to take this and I'm just going to drop it down here. This is how we're going to start. Now, so what I'm going to do is look at the triangle PQR and I'm just going to add up the three angles to give me 180 degrees. So alpha plus gamma plus alpha plus beta plus gamma. So when I add all these angles up, I should get 180 degrees. So let's write that out first. So we have alpha plus gamma. That's the angle, that is the angle at P, plus alpha plus beta. That's the angle at R, plus beta plus gamma. That's the angle at Q. They should all add up to 180 degrees. Angles in a triangle. Okay, so if we just look at this, we have two alphas, so it's 2 alpha. We have two betas, so we have two betas, and we have two gammas as well, and that they add up to 180 degrees. Let's just factorize out the 2 then. We have alpha plus beta plus gamma will give us 180 degrees. That means alpha plus beta plus gamma must equal 90 degrees divided across by 2. Finally then, gamma must equal 90 minus alpha plus beta. So I just brought these two over here. Okay, so that's as far as I want to go really in terms of the main part of the proof. But let's look at what we've ended up with down here. We have an angle, gamma, is equal to 90 degrees minus alpha plus beta. But if we look at this, what we were given in the question was alpha plus beta is greater than 90 degrees. If you look up here, alpha plus beta, these two here, we're told here in the question somewhere, alpha plus beta must be greater than 90 degrees. The angle R is greater than 90 degrees. So I'm going to say here is alpha plus beta greater than 90 degrees. We were given that. Therefore, gamma is less than 0, is negative, which is not possible. That's your contradiction. The angle gamma here is negative, and that's not possible. Therefore, by contradiction, O cannot lie inside triangle PQ4. Okay, and that's really it for this question. So not a particularly easy question, I think, that last part, but some of you may have gotten it fairly easily, but it took me a little bit of thinking about. Okay, that's it for this question.